Hello everybody, I'm Anupama Venugopal and I have 10 plus years of experience in the automotive software industry. When I took up this AI course a few months back, my idea was not to become a machine learning engineer or to switch careers, but rather to be able to leverage the power of AI to make me a better embedded software engineer. Let me tell you how I did this. I looked for some part of my work which was quite repetitive, monotonous and manual, and created an AI agent to handle exactly this part. So now in the video through which you would see, I have a AI assisted debugging workflow which runs 24/7 on the cloud, and when it receives the error logs from the customers, it analyzes those logs and gives a first pass analysis of what the probable root cause would be. So without much further ado, let's go and have a look.
If you have ever found yourself staring at a screen full of logs trying to find the underlying issue, this question probably hits pretty close to home. Let's see how the debugging is handled the old way. Starting by receiving error logs from the customer, it has to be manually or with the help of a debugger analyzed to check the flow of control and hence pinpoint any missing or faulty configuration, and then manually updating the Jira ticket. And of course there is. Presenting to you here is the new way, a 24/7 automated engine that's built to do all of that heavy lifting for you. And right away you see the results. Instead of the chaos, you get this perfectly organized folder structure. This system follows some simple but really powerful rules. The folders are divided into baselines, logs, reports, scripts. So here in the logs folder, you see against each customer folder name, there exists dated folders for each day so you can trace back the origin of the logs. In the reports folder, you get the generated mermaid state diagrams of the best case baseline and each error cases. Also, there is an index.html about which we talk in some time. So, let's now look at how I have automated this whole analysis. NUCT-N is the brain orchestrating this automated analysis. Also, this is how my NUCT-N workspace looks like. The trigger to this workflow is when there is an incoming customer email with attached error logs. The logs are downloaded and segregated to the customer specific logs folder which we saw earlier, and the color-coded master Excel sheet is generated. Then mermaid state diagrams for the baseline and error scenarios are generated and packed into an HTML page and uploaded into GitHub so anyone with access to project repository can take a look. Then the computed state deviation is given to an AI agent which analyzes the issue and computes root cause, and this is then formatted into an email format which then is sent to the developer via an email to ensure no action is taken without approval from human in the loop, after which comments are updated in the Jira ticket. In end effect, a scattered manual analysis chaos becomes a structured and scalable clarity. Let's now check out the cross time zone advantage with an example. At 8 p.m. in Mexico, customer finishes their day and emails over their error logs while they are logging off. 5 minutes later, the NUCT-N workflow is triggered. By 8:15 p.m., the log is passed, the dashboard is created, and an AI agent has already performed a root cause analysis. Cut to the next morning, 8 a.m. in Germany, a developer logs in, grabs their coffee, and finds a fully analyzed, triaged bug report waiting for them. This is the generated master Excel sheet. The leftmost column shows the best case scenario, or the expected behavior of the code, and the columns next to it, the error scenarios for direct comparison. States highlighted in red indicate a jump direct to the error handler. Here you can see the generated debugging dashboard. It provides a clear daily view for a specific customer and date. The baseline flow is shown first, representing the expected ECU behavior. Below that, the error scenario diagrams are displayed for direct visual comparison. This makes it much easier to spot deviations, skipped states, or abnormal transitions without manually reading through raw logs. In end effect, the dashboard turns debugging into a much more visual, structured, and reviewable process. And we have now reached the final step of AI-powered analysis to bring in some intelligence to make sense of it all, to generate a summary that a human can read and hypothesis about the root cause, all using an AI agent. And one important principle in this workflow is that automation does not mean removing human judgment. At this stage, the AI-generated analysis is formatted into an email and sent for review. The engineer can then review the likely root cause and accordingly approve or reject the root cause analysis, after which comments are automatically updated into the Jira ticket. Showing next a glimpse of my GitHub page where you can see all the details of this project and future modification plans, and you also find the dashboard link directly on the home page. Summing up the takeaway here, starting of the day, the engineer gets this complete analysis package, which means they can spend their time fixing the problem, not just trying to find it.